Good morning, students. This is Muhammad Adil, and today I'm here to welcome you on the engineers classes. Friends, I'm here to teach you the mathematics of class 9th, cbse. So this is the introduction class where I will be making you understand how to tackle the syllabus of class 9th. The present scenario that is going through this nation and even the whole worldwide, this COVID-19 situation. So here we believe that there's a huge loss of the education of the students is going through. So in order to cope with that situation, we have decided to start another series of this academic classes of 9th and 10th both. So initially I'll be taking classes of 9th. Meanwhile, in the time of a week or 10 days, I'll be further taking the classes of both 9th and 10th. So as far as mathematics is concerned, my way of teaching will be a bit different from whatever you have understood or learned in your school and other coaching institutes. Look, I'll be taking the class with the help of examples, with the help of practical situations, not only just cramming through the mugging up the concepts, but also understanding the concepts. So the first chapter that which we will be dealing with in this particular series is number system. So students, the number system is itself a huge variety of chapter, but this number system, let's start with this. Actually, any number that may come across to your mind, just think in your mind that any number, let's say if you thought 2, if you thought 3, if you thought 4.001, if you thought 0.0010001 and so on. Let's say you thought 25,000. So all that number which you thought right now are actually real numbers. Similarly, there is another classification of the numbers that is called imaginary numbers. So here, as if now we will not be dealing with imaginary numbers because this is something which is in class 11th. So this is not your part to study right now, okay? We will be dealing with real numbers only. So for classification, number is classified in two: imaginary and real. Imaginary and real, as if you like you have just completed your class 8th. So whatever the numbers you have come across till now are real numbers. Imaginary number are completely different, so don't even think about this or what are natural imaginary numbers and all. So whatever you have read by now till class 8th, that all is real numbers. Now the real numbers are further classified into rational numbers and irrational numbers. Rational numbers and irrational numbers. Clear? Now this rational number is further classified. Like this rational number is not exactly classified, but this rational number can be of many types, okay? It can be natural, it can be integer. Actually, the classification is quite big. So if I rub this down, this is not your part right now. Clear? We will further be dealing about this of irrational number part. You have heard this name, this word, this term for the first time, rational number. Clear? So let's begin with the basic that you have already know by now. You know natural numbers, right? I'll be quick in explaining this because this is something that you have learned few years ago. That is a very long time. Natural numbers are counting numbers. Natural numbers are counting numbers. Encircle it. Why encircle? Because whatever number is used for counting is natural number. For example, if you like there are 10 friends of yours are standing in a row, your teacher tell you to count those students, those your friends. What will you do? Will you start counting from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 like this, or you'll start from 1? For every counting that you do, the number starts from 1 till and goes till infinity. So the number starts from 1, 2, 3 and goes till infinity. This is the sign of infinity, means there is no end. Similarly, there is second one. The second is whole number. The second is whole number. So don't get confused with natural number and whole number. Just add an extra 0 to it. Just add an extra 0 to it till infinity. Till infinity, just add an extra 0, that will be called whole numbers. Then comes the role of integers. Integers are natural numbers, 0 and negative natural numbers. So think of a negative natural numbers. It is -5, -6, -3, -2, -1, 0, 1, 2, 3, so on till infinity. Clear? So I believe that you have got to know whatever these things I have taught right now. There are further classifications. Let's go through that. You may come across the decimal part as well. For example, if you come to know a number called 0.5, if you come to a number 0.7, if you write a number 1.76. So students, these numbers are actually decimals. Okay, these numbers are decimals. So decimal is also a part of a set of this number system. Okay, this is part of a real number part. So this decimal is further classified into terminating and non-terminating. Terminating and non-terminating. This non-terminating is further classified into recurring and non-recurring. So I want you to be very honest with me during the class. Decimal is something with which you are already familiar. This terminating, non-terminating, recurring and non-recurring, these are 4 terms that are new to you. Okay. So terminating, by the term itself, represents that it is finished. If someone is terminated, means that that person, like that thing or that product is finished. Clear? So if it is written this way, 1.76. If it is written this way, 1.76. So it is terminated. It is terminating decimal. Why terminating decimal? Because there is no further digits after 6. Clear? 0.5 is terminated. So it is called terminating decimal. 0.7 is terminated. So it is called terminating decimal. Now let's go through the non-terminating decimals. Let's say if you come across a number 1.333 and you see a dot, endless dots, okay, or if you see somewhere written like this. So these two resemblance of the numbers or the decimals say that these are not being terminated. This dot represents that this 3 is going to be continued, and this is called bar. Like the straight line over 3 is called bar. So when you see a bar above a number, over a number, it says that, it represents that the number gets repeated all the times. Clear? So remember this. So these are non-terminating decimals. Clear? Now you may think that, sir, how come is it so that you wrote this and these numbers? So students, I wrote these numbers just randomly. Okay? You just think of any number that has decimal. You think of any number that has decimal, and that decimal part would either be, like that particular number would either be terminating or non-terminating. If you think of a number something like this, where the digits gets over right there, that number is terminating, and if the digits remains to be continuing, the decimal is non-terminating decimal. So by now you have get to know the concepts of terminating and the concepts of non-terminating. Now there are two new terms, recurring and non-recurring. So if you have cleared the concepts by now, let's go through the last classification of recurring and non-recurring. Okay. So recurring means something that repeats. Something that repeats. So recurring can be said as repeating, and or non-recurring means non-repeating. For example, if you think of a number 1.724 724 and so on. So students, tell me the set of numbers which are repeating here. The set of numbers which are repeating here is this 724, this particular section is continuously repeating itself. Is it so or not? It is. And I have already told you that part which is repeated can be written with the bar over it. That part which is repeated can be written a bar over it, with a bar over it. Okay. Now, this is something which is the example of recurring. Clear? This is something example of recurring. Let's note it down, and further I'll go with the non-recurring part. I hope you have noted it down. Now non-recurring. 1 point, let's say 4.01, clear? 0, 2, 0, 0, 1, 0, 0, 2, 0, 0, 0, 1, 0, 0, 0, 2. So students, the number that come across the board is 4.0102, 001, 002, 0001 and 0002. So you cannot observe a pattern over here, and moreover this dot represents that the number is still continuing. The pattern, although there is a pattern, but that pattern is not repeating. Mind it, there's a difference. Of course there is a pattern, okay, but that pattern is non-repeating. So friends, where is the pattern? So you will say, sir, there is a pattern in a way that first you write 0102, then you wrote 001 and 002. So here you got a pattern, but is that pattern repeating? No, of course not, absolutely not. That pattern is not repeating. And if that pattern is not repeating, this is a perfect example of a non-recurring decimal. This is a perfect example of a non-recurring decimal. Clear? Whatever I have told you right now, you might be thinking, sir, one thing is left. Like you have taught decimals, you have taught natural numbers, you have taught integers, whole numbers, but there is something which is still left. That is fractions. Of course, these fractions are a part of a number system, are part of a real number system, like real numbers. So fraction, like if you write a 3, put a line under it, below it, and write a 5. So this way of representing a number is called fraction. Like this particular thing is a fraction. Now this upper part is numerator and this lower part is denominator. Clear? I urge you to stay here right on the class, because the video is particularly going to proceed with more detailed concepts. Till now, I was just trying to recall the concepts that you have already read in your past classes, okay? But now the thing is very important. Now the thing goes very important because, why? Because, look, this is the Venn diagram representation. This is the Venn diagram representation. And trust me, this is the most valuable part of this lecture. This is the most valuable part of lecture. Why? Because if you have a set of natural numbers, if you have a set of natural numbers, like if you have a bag or a circle, so in that circle, in that bag, that balloon, you have only the natural numbers. But if you got an extra zero, if you got an extra zero from somewhere else and you collected it and put it to the bag, so this zero, by adding this zero, this particular line becomes, this particular circle becomes the circle of whole numbers. Further, if you get negative natural numbers, extra from somewhere else, this particular set becomes I stands for integers. Clear? There may be some other denotions in your books, but for easy remembering, for easy recalling, I've just taken the first letter of the particular term. N for number system, W for whole number, and I for integers. So in natural numbers we have 1, 2, 3, 4 and so on. And in this particular you have a 0. You have a 0 in it. Clear? And this integers we have -5, -6, -3 and so on. So I hope that this will be able to convey, like I'll be able to convey the proper content of the particular things. So this is number system, this is natural number, this is whole number, this is integers. So what else I have taught by now? What else I have taught till now? Till now, let's take a halt. Try to understand. This is a circle of integers, but do all integers are whole numbers? The numbers written outside this particular circle are integers, but or do all integers are whole numbers? Remember my point, do all integers are whole numbers? There's always a confusion that do all whole numbers are integers, or let me write it, all W are I or all I are W. Which one is correct? All W are I or all I are W. So friends, this W is within the boundary of I. So whatever the W is here, whatever the whole numbers are there, that lies within the boundary of I. But whatever the integers you may write, that is not within the boundary of whole number. There are some others which are outside this whole number. It means all whole numbers are integers, but all integers are not whole numbers. So this is right and this is wrong. So this was the importance of this particular Venn diagram representation.